Hi everyone, welcome to another bacterial genomics tutorial session. In today's video, I'm going to show you how you can identify antimicrobial resistance genes using the tool STARAMR. So what we are going to do is to use STARAMR to scan whole genome sequences of 2 Salmonella enterica cerever isolates. That's what we are going to do. So this tutorial was made using the original STARAMR tutorial, which can be found here. I'll leave the link to this page in the description box. So just reproducing what has been given here. If you also want to read more about STARAMR, then you can check the main GitHub page, which is here. The link to this page is also in the description box. So just take note of that. So that's basically what we are going to do. In order for you to follow this tutorial, you need to make sure you have a Unix-like operating system, and you should also have Mamba installed. We'll use Mamba to install STARAMR. So take note of that. So the installation instructions for Mamba can also be found in the description box. So just check the description box, you'll find a tutorial that shows how to install Mamba. So just check that out. So now we are going to open our terminal and then start the exercise. So let's start. Perfect. So I am on the terminal now. So that's what I'm going to do. I'm first going to install the STARAMR tool. So because I'm going to use Mamba, I need to first add channels. So when you set up Mamba, Conda 4 is already installed. So you just need to add one extra channel, which is bioconda. So I'll say conda config add channels, and I'll say bioconda. Perfect, that has been done. So let's take a look at our channels. I'll say conda config show channels. So this will list the channels I have. So I have bioconda, I have conda forge. If you don't see conda forge, then try to install it using the same approach here. So you just have to call this, and then instead of bioconda, you add conda forge. So make sure you have that. Perfect. So now we have it done. So what we are going to do next is to create an environment and install STARAMR in it. So I'll say mamba create -n. I'll say STARAMR. Okay, so this is the name of the environment. Now we need to specify the tool. So the tool is also called STARAMR. Perfect. So now we can execute this command to install STARAMR. Okay, so let's type Y to confirm. So once you do that, Mamba will download all the necessary packages, install, and configure them for us. So that's how we do it. Okay, STARAMR has been installed. So let's continue. Now we are going to test STARAMR. So we need to first activate, and we'll do that using this command. So let's continue. So I'll say Mamba activate STARAMR. So this will activate the environment first. So now we are going to do a test. So we will issue this command. Let's check the GitHub page. Yeah, we will use this command to just test. So we say STARAMR db info. So I'll go back to the terminal. So I'll say STARAMR db info. So once we do this, should list the databases for us. Take note that what STARAMR does is to scan the context against these databases. So that's what we are going to do. So what we are displaying are the databases. So once the databases have been displayed for us, that means that everything is looking good. So now we can continue. Now let's clear the screen and continue. So now STARAMR is working, and so we need to download the example data and then use them. We are going to use the genome assemblies of 2 Salmonella enterica cerever isolates. But before we do that, let's create a directory and then cd into it. So I say make the salmonella, and then I'll cd into it. Perfect. Now that is done. Okay. Now before I continue, let me also say that all the commands that we are going to use, you can find them here on the original tutorial page. Alternatively, you can also download the ebook which I've prepared. So this ebook has all the commands in it, so you can just check the description box. The link to this ebook, the download link is in the description box. So just use the description box, find the link there, and then download the ebook. So either way, it's fine. Okay. Now let's continue. We have created our directory, we have cd into, so now we are going to download the example data. So if you take a look at the original tutorial, we have the data sets here. We have this genome assemblies we are going to use. Okay, so you can click on them. Let's click on the first one, and then you send to this page. So here, come to the right side and then select the FTP directory for refseq assembly. So click it, and then you'll be sent to this page. So we will download the first A file. So we will download this one, the .fna.gz. That's what we are going to download. Okay, so you can use your browser to download by clicking, or you can use the command line to do that. I'm going to use the command line to download. Okay, so that's what I'm going to do. I'll right click, and then I'll copy the link, and then I'll move to the terminal, and then I'll say wget, and I'll say -o, and I'll name it as isolate1.firsta.gz. Okay, the -o indicates that when we download, the file should be given this name. Okay, when you download, it comes with a default name, but we want to use this one. It's a compressed file, by the way. So once you do this, then you just paste your link there. Okay, and then you can download. Okay, so just make sure to download. So let's execute this command. Perfect. So now it is downloading now. Okay, that file has been downloaded. So let's do an ls. We are going to find the isolate one here. Okay, so let's decompress it. So we will say unzip isolate1.firsta.gz. Now let's do an ls, and we are going to find that file there. Okay, so there's a first A file. Now let's download the second one. So let's go back to this one. Let's right click this link, open in a new tab, and then go to the FTP refseq assembly, and then we get our .fna.gz. So I'll just right click, copy the link. Let's do it again. Right click, copy the link, move to the terminal, and say wget -o. This will be isolate2, and then you supply your download link. So let's execute this command. Perfect. The file has been downloaded. So let's do an ls. We'll find it there. Let's decompress it. So that'll be what? unzip isolate2.firsta.gz. Perfect. So do an ls, and you're going to find your first A files there. Now let's continue. We are going to move all these into another directory. So I'll say make the sequence, and I'll say mvin star.firsta, and I'll move them to sequence. So do an ls, you'll find your sequence directory, do an ls into it, and you're going to find your first A files. Perfect. So now we are going to run STARAMR, and then supply it with the sequences here. So let's go back to the documentation. Let's check the usage Yeah. So if you want to use STARAMR to identify AMR genes, then you need to use this command. Okay. Star search, and then you specify your output directory. Then you also indicate your FASTA files. Okay, that's how we do it. But for our tutorial, we are going to use this one. We are going to include acquired point mutation resistances using pointinder. Okay, so we are going to use this command, this syntax. Okay, the reason why we are doing this is that currently pointinder database supports the salmonella organism. Okay, and that is why we are including that in our tutorial. Okay, so if you have a salmonella organism, then you can include the point finder organism. I repeat, if you are dealing with a salmonella isolate, then you can use the point finder organism option to identify your point mutation resistances. So take note of that. So currently the point finder organism option supports salmonella as well as these other organisms. Okay, so if you are dealing with these organisms, then you can use the point finder organism option. So we are going to use this syntax. Okay, all other settings will be defaults. So that's how we are going to do it. So let's get back to our terminal and then issue our command to get our AMR as well as other stuff. So in addition to the AMR, we are also going to search for plasmids. We're also going to do some multi-locus sequence typing. So anyway, once we get the results, you know what I'm talking about. So let's run STARAMR. So to run STARAMR to identify your antimicrobial resistance genes, you say STARAMR, then you say search, and you add your point finder organism option. So I say dash dash point finder dash organism, and I indicate salmonella, and then I'll say dash O, and I'll say outputs. So dash O here indicates that the directory called output should be created. In that directory, all the output files should be stored there. Now let's specify our FASTA file. So I'll say sequence / star.fasta. So let's execute this command. Okay, STARAMR has completed its work. If everything is successful, then you are going to see this message. Okay, you are also going to see these messages. For these messages here, they are warnings, so you can ignore them. Okay, it's just a warning. In some cases, you may see this message or you may see these messages. Okay, these messages here. So when you see this, don't worry, we are going to resolve it. So this is happening because one of the commands is not compatible with the version of pandas that has been installed. Okay, so that is why we have this error message coming up. So to resolve it, we simply have to remove pandas, the current version by the way, and then install an older version. Okay, by the way, pandas is a Python package. Okay, so that's what we are going to do. So again, if you see something like this and this, it's fine, everything has been done. But if you see this, then we need to resolve it. So we are going to resolve it now. So let me show you how it's done. So let's first clear the screen, and then we are going to uninstall the pandas version we have at the moment. So I'll say pip uninstall pandas. I'll type Y to confirm. Okay, so as at the time of making this tutorial, this was the version of pandas that was installed. Okay, when I was trying to install STARAMR. So this is where the issue comes from. So we are going to install an older version. So now we are going to reinstall pandas. I will specify an older version. So we say pip install pandas and we say equals 1.5.3. This one worked for me, so that is why I'm using this. but you can experiment with other versions as well. Okay, so let's execute this command. Okay, the pandas version we specified has been installed, so now everything is going to be fine. And by the way, I have already raised this issue on the GitHub page of STARAMR. So the developers sent me a message that they are going to resolve it. So it's likely in the next version of STARAMR, the error that you saw may not come up. Perfect. Now let's continue. Now we are going to rerun STARAMR. So let's clear the screen and let's do an ls first. And it's likely we are going to see the output directory, the one we specify. So we need to remove that. So we say rm-fr and then we specify that directory. So let's remove it first. Okay, that has been done. So now we are going to run STARAMR again. So we say STARAMR and we say search and we indicate our point finder organism, and that is Salmonella. And then we specify an output directory. So we say -o output and we specify our fast A file. So we say sequence /star.fasta. So let's execute this command. Now let's wait for STARAMR to complete its work. Okay, STARAMR has completed its work, so now we can proceed. So what we are going to do next is to explore the file. So let's clear the screen first and let's do an ls. And we are going to see the output directory, the one we specified when we were running STARAMR. Now let's ls into it. So we say ls outputs and we are going to see the files here. Okay, these are the output files. Okay, so what we are going to do next is to explore these output files. So we are going to look at the results. So let's continue. Now, before we explore the output files, let me also say that a description of each of these files can be found on the STARAMR GitHub page. So if you go to the GitHub page, just scroll down to the table of contents and then check for outputs. This one here. So click it and you'll be sent to the section which has the descriptions. Okay, so these are the output files. So you can also scroll down to see examples and then further descriptions. Okay, so just scroll down and then you can see everything that is there. Okay, so that's what we are going to do. So basically we are going to explore the files using some Linux commands. Okay, so let's go back to the terminal. Okay, so we are going to continue. So we've already done an ls to the output directory, the one which has the files. So let's take a look at the first file, and that is the summary. So the summary file contains, that's this one here. The summary file contains a summary of all results that has been given or that has been generated. So it's just a summary of everything, the activity, okay, the STARAMR analysis. So we are going to explore. So if you want a quick information, a quick overview, then you just have to explore that. And that is why we are going to start with that. So this has been given us .tsv. So that means it's a tab separated file. Okay, so we can explore. Okay, so first of all, this file here can be opened using a spreadsheet software. So let me just open for you to see. Okay, so this is the output directory. So just open it and then you are going to find a file. So this is the summary file. Okay, so all the others are also .csv. So that means you can also open all these other files using a spreadsheet software. And there is an Excel file also here. Okay, and you also have this, but let's start with this one. So you can open it using your spreadsheet software. I have mine here. Okay, so when you open it, you are going to see this. Okay, so you have your headers let me just zoom. Yeah, you have some others here. Okay, you also have your hits. So we have isolates as well as the discoveries made. Okay, so basically, if you're dealing with lots of information, then it will be very cumbersome trying to open them with a spreadsheet software and then manually checking them. So that's why we are going to use some Linux commands to do a quick check, okay, to scan through quickly and then get a general overview of what we have done. Okay, so that's what we are going to do. So I will refer back to this one later. Okay, now let's go back to the terminal. So on the terminal, we can use the cat command. So we can say cat and we say output slash summary.csv. And this will list everything here for us. Okay, fundamentally, it's a text file. That's what you need to know. But if you look at what has been displayed, it's kind of it's everything has been bundled together, so it becomes very confusing. So we are going to properly format the outputs. Okay, so we are going to use the column command to try and then format it. So we will say column and we say -s dollar and we say comma quotes /t and we say -t and we say output /summary.csv. Okay, so the column command simply aligns the columns in this file and then prints a table which is tab separated. Okay, that's what it is. So let's execute this command. Perfect. This is what we have. Okay, but what we have here, we can still make the display better. Okay, so we will do this by subsetting the columns in different commands. So that means that we are going to take a look at some of the columns, okay, in different commands. Okay, that will also help us to easily understand what's going on. So we will start by displaying only the genotype. Now let's go back to the spreadsheet. We have the spreadsheet somewhere here. Let's check. Yeah, so we have the spreadsheet with the columns. So we want to display the genotype, which is this one here. Okay, so with the genotype, you can also look it up online. We will do that later on. So we have this and we have this. Okay, so those are the names for the AMR genes. Okay, those that have been identified. So we have column 1, column 2, column 3, 4, 5 in that order. Okay, so the genotype is what? Column 3, and then the isolate ID is column 1. So we are going to issue a command to display the first and then the third columns. So I'm using this opportunity to also give you some Linux tricks, okay, for processing text files. So let's continue. Let's do an ls again, and then let's issue that command. So we are going to use the cat command. So we can say cat -f and we say 1,3 and we say output /summary.csv. Okay, so this will display everything for us. So we have our isolate ID. Remember, we had 2 sequences. Okay, so these sequences are for different isolates. So we have isolate 1, isolate 2. So isolate 1, this is what was identified. Isolate 2, we had more than 1 hit. Okay, so we have this, and all these ones. So these are all antimicrobial genes, antimicrobial resistance genes that were identified in isolate 2. So isolate 1, we have just 1. Isolate 2, we have more than 1. So we have all of them here. Okay, so that's what we have now. Now let's continue. So we are now going to show the predicted phenotype. So let's do that. So to do that, we will use the cat command again and say -f1 and this time column 4 and we say output /summary.csv. So let's execute this command. So now we have the predicted phenotype. So we have isolate 1. From what we have here, it shows some resistance against ampicillin, amoxicillin, and then these other ones. And we have isolate 2. These are the predicted phenotypes. So these are the drugs or compounds that this organism is, or this isolate is resistant to. Okay, so that means that these genes here have been reported to be responsible for this resistance. Okay, so that is what we have here. Okay, let's try to see if you can improve this display by adding the column command. So I'll add another command. So I'll say column -s dollar, and I'll bring my column command again like this, and then I'll display. So let's see. Okay, so I have this also done. Okay, so there's really not much of a difference. The only difference is that here the tab separation is enforced. Okay, so that is what is different from this and this. So going forward, we are going to combine the cat command and then the column command to give us a good output. Okay, a nicely formatted output. Perfect. So now we have the genotype and the phenotype. Now let's take a look at the plasmids. Let's check if plasmids were identified. So we are going to do that also here. Let's ls again into the output directory. So we will still use the summary.tsv. So if you take a look at the column, let's go back here. This is the column for plasmid. Okay, so the column is what? 1, 2, 3, 4, 5. That is 5. So that means we have to use 1 and then 5. So I will do that here. So I'll just say cat-f1 5 output/summary, and then I'll bring my column command. You can choose to omit these ones and the command will still work fine. Okay, so let's execute this command. Perfect. So now we have our plasmid. So in isolate 1, 2 plasmids were identified. In isolate 2, 1 plasmid was identified. That is what we are. So what we are doing is to get a summary of the hits. That's what we are doing now. Okay. You may also want to look at multilocus sequence typing. Okay, so you can also do that by checking the summary file. So let's go back to the spreadsheet and then let's look at what we have. So we have this. We're also going to look at this. We are going to look at this. Okay, these are the things we are going to look out for, or we are going to check basically. Okay, so we will go back and then check. So we will say cat-f167. These are the ones we are going to check. And then we say output/summary. And then we execute the command. So this will give us the scheme, the mlst. Okay, so that's what we have. So we have this and this. Let's enforce the tabs. So I'll add this command to it, the column command. Perfect. So now you will see that the display here is better than this one. Okay, at least you can see the headers and then their respective rows. So we have the scheme and we have this. Okay, so the scheme here tells us that indeed we are dealing with Salmonella enterica isolates. Perfect. So that's what we have. So we have the mlst also done. Now there's something we forgot to do, so I'll just do that here. We could have also checked the headers for the files here. So I think I'll use that to also let you know. So I can just say head-n1 output/summary.csv. So this will give us the headers. Okay, that's the first row. Okay, you could have also done that to check the headers, but I thought it would be much easier if we use the spreadsheet software to quickly check. Okay, so that beginners do not end up getting confused. Okay, so now let's continue. Now, if you want details of the result, then you have to check the individual files. For example, if you want details about the antimicrobial resistance genes, then you have to check the resfinder result file, and that is this one here. Okay, so what we are going to do is to explore this file. So I'll clear the screen, I'll do an ls again into the outputs directory, and then I'm going to explore the file here. Okay, there's the resfinder.tsv. Let's open it with our spreadsheet software first. Okay, so this is the file. I'll open it now. So when you open it, you can check the headers to look at the available information. We are going to explore, but we will look at some of the columns. The rest I'll leave to you to do. Okay, so this tutorial is to serve as an intro so that you can take it up from there. So we'll just look at some of them. Okay, so we are going to look at the columns here. Okay, so let's take a look at the columns. We will just look at some of them. So we will look at the isolates, the gene, predicted phenotype, and then we also look at identity, and then we can look at the accession number, stats, and all those ones. So all those ones are here. We'll just look at some of them, okay? And then you can later decide what you want to do. Okay, so let's go back to the terminal. So we will say cat -f 1 2 5 6 7, and then we bring our column, and then we indicate our file. So that will be output/resfinder, and then we bring our column command to properly format the outputs. So let's execute this command. Perfect. So now we have that done. So here we have isolate ID, gene, overlap, HSP length / total length, quantic, etc. Okay, so that's what we have. So you can just use this information to explore better, to explore more, by the way. Okay, I repeat, you can use this information to help you explore. Okay, now let's add another column. Let's say column 8. What do we have? We have stats. We can add others as well. Okay, so let's say 9. That's end. Let's add another column. This. Okay, I'll remove one of the columns here. Let's say 5. Let's clear the screen and then do it again. So let's issue this command to see what we have. So we have this, and so with our session IDs here, you can also look it up. You can go to NCBI and then look up the session number, and then you can get more information about the gene or the genes of interest. So just take note of that. Now let's continue. Now let's take a look at the point finder file. The point finder file gives us information about acquired point mutations and plasmids that leads to or leading to the antimicrobial resistance phenomenon. Okay, so we are going to look at that. Let's just confirm the information here. So we have that here. So it says the point finder file, it shows all the acquired point mutations and plasmid genes leading to antimicrobial resistance. Okay, so that's what we are going to look at also. So we are going to look at the columns, not all the columns, by the way, some of the columns. Okay, but if you decide that you want to look at all of them, that's fine. You can also check, but I'm only introducing you to this two. So let's do an ls into the output directory again, and then let's take a look at the points finder file. So we have that here. So I'll say cat-f1 2. Let's take a look at the columns again here. So we have 1 2 5 6 7 8 10. We will just look at some of them, not all. Okay, so let's say 1 2 8. The output slash point finder.csv, and then we bring our column command to properly format everything. Okay, so we have that here. Let's add extra columns. We have that. So basically you can check, you can just add more columns to see what will be displayed. That is up to you. So let's continue. Now you can also check for the plasmids again. So let's take a look at the file which can give us information about the plasmids. Let's do that. Let's ls into the output directory again. So we have plasmid finder. So this will give us information about the plasmids. Okay, so let's take a look at the columns that were displayed. Let's check. So we have columns 1 2 4 5 6 7. Let's see. So I'll say cat-f 1 2 4 5 6 7. Output slash plasmid finder. And then I add my column command. So we have that also here. So we have plasmids and we have other information here. Okay, so that's what we have. Okay, now let's continue. Now STARAMR also does some blasting. Okay, so it does blasting to identify the antimicrobial resistance genes. So if you want to take a look at the blast hits, then you can also check the hits directory. Okay, so you can say ls output slash hits, and we're going to find the blast hits for the plasmid finder, resfinder, and then the points finder. Okay, so all those ones are here. So you can check if you want to get more details about the hits. Okay, so now let's continue. There is also another file called detailed summary. This file contains a summary of all the results in a single table. Okay, so genes found from resfinder, plasmid finder, and then point finder are all in this table. You can also check that. So this is the detailed summary. You can also explore that. So let's just explore. Let's do a quick exploration. So we say cat-f 1 2 4 7 11. We say output slash detailed summary.csv. Let's add our column command. And then let's say -t here. So we have this here. Okay, now let's rerun this command, and this time let's add -n to see what comes up. We also have a similar result here. So we have this, okay, but you can subset. Let's clear the screen first. You can subset everything here and then just display some of them. Okay, or alternatively you just open with the spreadsheet software. So let's execute this. So we have that also here. Okay, so we have some information here. So basically everything is here. So just go all out, try your Linux commands to explore. This tutorial is only giving you an intro. Okay, so that's what we have. We can also take a look at the settings that were used for the AMR detection. Okay, so if you take a look at the output directory, you have settings. You can display, so I will say cat output / settings, and it will tell you the settings that were used. Okay, maybe you may want to look at the settings for debugging purposes. You can check that file and then see what was done. So it's important. Sometimes you may want to investigate further, and it's important you learn, or you know how the tool works. Okay, so this will help you to do that. Now let's continue. Now with what we have, it's possible to validate. Okay, so we can validate the results we have by comparing to information available on the NCBI database. We have two isolates. Let's take a look at them. Let's say ls sequence. Okay, we have isolate 1 and 2. So we can find out more about these isolates. Okay, so validating the results will help us to be confident, okay, of the results that we have obtained using STARAMR. Let's go to the STARAMR tutorial page to check. So we have isolates 1 and 2. Okay, so on the STARAMR tutorial, it gives us links that we can use to validate our results. We can search for the genotypes and then the phenotypes, that's the predicted phenotypes. Okay, so we have the pages for isolate 1 and then isolate 2. So let's take a look at them. We will start with isolate 1. So for genotypes, there's the link. Let's open it. Let's start with the genotype. So we are opening this one and then we can check. So this is for the genotype. So on this page, just come to the right side, and we're going to see these ones here. So we have these ones here. We have AMR genotype. So let's take a look at this one here. Let's open our summary file again. And then we can see isolate 1. We have this gene here. Okay, so this is what we are seeing on this page. Okay, so this let us know that things are good. Okay, now let's take a look at the phenotypes for isolate 1. So this is the page. Let's open this link. And by the way, I will leave the links to the pages in the description box. So just use those links to visit the pages. So now we are taking a look at the phenotype. So this is it. So when we are here, just scroll down and then you see a table here. We have antibiotic resistance phenotype. We also have this, but we are looking at this and this. So we have the antibiotic. Okay. Now let's take a look at our summary file again for isolate 1. So we have isolate 1. We have the predicted phenotype. We have these antibiotics, this. Okay, and we see them here. We have this, we have this one, we also have this, and then this. Okay, so we are seeing them also here. Okay, so things are looking good. Now let's look at isolate 2, and that is this one here. Okay, take note that we renamed our files. Okay, we use isolate 1 and 2. Okay, but this tutorial used the session IDs here, so that's why you are seeing GCF blah blah blah, GCF blah blah blah. Okay, now for isolate 2, we have that also here. So just right click, open for genotypes, and then you see the information here. Okay, so we have all these ones here. Okay, so we have complete and we also have points. So you can look at these ones and you can look at what you have in the summary file. Okay, so let's take a look at this one, for example. That's APH blah blah blah. We have that here. Okay, you can also check and then compare what you have here to the one in the summary file. Okay, so I will leave that to you. Now let's take a look at the phenotypes. So we have this. Let's open it. We are going to see our table here. So you can take a look at what you have. Let's look at the summary file. For isolate 2, we have the phenotype. Let's see. Okay, gentamicin, etc. Let's just look at gentamicin. Let's check. We can see it here. Okay, you can also check for these antibiotics. So I will leave that to you. Okay, so that's it. So let's get back to the STARAMR page. What we've done so far was to use links that have already been given to us. Okay, we have those links here. But sometimes you may want to search for the information yourself. So it's possible to search for the information using the session IDs. Okay, so I'm going to show you that here. So if you are going to search for information, okay, for example, the genotypes, if you want to search for information on the genotype, then you need to visit this page. Okay, we have that here. So when you are here, you can just search. Okay, all I have to do is to input your session ID here. So let's take a look at isolate 1, which is this one, for example. Let's copy this session ID. And then let's paste here. And then let's search. Okay, so once you search, okay, if your session ID is correct, then the page will be open for you. So we can see the page. Okay, this is what we did. Okay, previously we visited this page. Okay, but now we are searching ourselves. Okay, so this is how we do it. You can do the same for the phenotypes as well. Let's just try with this one. So here we have the biosample, which is here. There's the session ID. You can just search. Let's just copy this text. Let's see. I'll just copy this one. Let's see if I'm able to copy. Okay, so I'll just paste it here. Okay, so I have it here. So I'll just search. Okay, and I have that here. So you can just check what you have. So, okay, so this is how we search for information. Okay, so that's about it. So in a nutshell, STARAMR can help you to identify antimicrobial resistance genes, plasmids, and then other stuffs. Okay, but we've just covered a few aspects of it. Okay, so it's up to you to explore and then check and then use it for to solve your needs, okay, or to answer your biological questions basically. So just check the page here. You have this tutorial to help you get started. Okay, and you can also check the description box for other useful links which I'm going to post there. And then I'm going to try and then make other tutorials on STARAMR as well. So just make sure to come back and then check all those ones as well. Okay, so that'll be all for this tutorial. And you can also check this other tutorial which shows you how to use aggregate to identify antimicrobial resistance genes as well as virulence genes.